June 6, 1944. Omaha Beach. Obergefreiter Hans Weber crouched behind a concrete bunker overlooking the chaos below, his Kar 98K bolt-action rifle hot in his hands. He had been firing at the American soldiers struggling through the surf for over an hour. 5 rounds worked the bolt, 5 more rounds worked the bolt. His hands were cramping from the repetitive motion. Then he heard it. A sound that would haunt German soldiers for the rest of the war. A metallic ping followed immediately by a rapid series of shots that seemed to come from a single weapon firing as fast as a machine gun. 8 shots in less than 5 seconds. Then another ping, then 8 more shots. Weber looked at his rifle, then at the Americans advancing up the beach. They weren't carrying bolt-action rifles, they were carrying something else. Something that fired as fast as a man could pull the trigger. Something that gave one American soldier the firepower of 3 Germans. The M1 Garand had arrived in Europe, and German engineers were about to learn that they had made a catastrophic mistake in weapon design philosophy. The story of why German engineers came to admire and fear the M1 Garand begins not in 1944 but in 1936, when the United States Army made a decision that seemed insane to European military experts. They adopted a semi-automatic rifle as their standard infantry weapon. Every major army in the world used bolt-action rifles. Germany had the Mauser Kar 98K. Britain had the Lee Enfield. The Soviet Union had the Mosin Nagant. These were proven designs, reliable, accurate, easy to manufacture. The idea of giving every soldier a semi-automatic rifle seemed wasteful, unnecessary, and tactically questionable. Military theorists of the 1930s believed that volume of fire would lead to ammunition waste. Soldiers would panic and empty their rifles without aiming. Semi-automatic weapons were seen as specialist tools for specific roles, not general infantry weapons. The United States disagreed. In January 1936, the M1 rifle designed by Canadian-born John Garand was officially adopted as the standard service rifle of the U.S. military. It was chambered in .30-06 Springfield, the same powerful cartridge used in American bolt-action rifles. It held 8 rounds in an internal magazine loaded by an unblocked clip, and it fired as fast as a soldier could pull the trigger. German military observers who learned of this decision were puzzled. Why would the Americans waste resources on such a complex weapon? The Kar 98K was simpler, cheaper, and more than adequate for infantry combat. One German analysis from 1937 concluded that the American semi-automatic rifle program was a waste of money that would provide no tactical advantage. They were catastrophically wrong. John Cantius Garand was born in Quebec, Canada in 1888. His family moved to Connecticut when he was 11 years old. Young John was fascinated by machinery and weapons design. He had no formal engineering education but possessed an intuitive understanding of mechanics that was extraordinary. By the 1920s, Garand was working at the Springfield Armory in Massachusetts, designing weapons for the U.S. military. His goal was simple but revolutionary: create a rifle that would give American soldiers overwhelming firepower advantage without sacrificing reliability or accuracy. The technical challenges were enormous. A semi-automatic rifle had to extract the fired cartridge, eject it, load a new round, and cock the hammer all automatically using energy from the fired cartridge. This required precise timing, durable parts, and ingenious engineering. Garand experimented with different operating systems. Gas-operated, where propellant gases were tapped off to cycle the action. Recoil-operated, where the force of the recoiling barrel cycled the mechanism. He tested hundreds of designs, each one failing in some way. Too complex, not reliable enough, too heavy, too sensitive to dirt. The breakthrough came in 1928 when Garand developed a gas-operated rotating bolt system that was brilliantly simple. A small hole in the barrel near the muzzle tapped off propellant gas. This gas drove a piston that pushed an operating rod. The rod rotated and unlocked the bolt, extracted the spent case, cocked the hammer, and loaded a fresh round. The entire cycle took a fraction of a second. The rifle fired, cycled, and was ready to fire again before the recoil even reached the shooter's shoulder. But making it work reliably was another challenge entirely. The M1 Garand went through years of testing and refinement. The military conducted trials that would have destroyed lesser designs. They fired thousands of rounds without cleaning. They buried the rifles in mud and sand. They froze them, baked them, and subjected them to abuse that no soldier would ever inflict. The Garand kept working. In 1936, after nearly a decade of development, the rifle was finally approved for service. Production began slowly. The Springfield Armory and Winchester Repeating Arms Company began manufacturing M1 rifles for the U.S. military. By 1941, when America entered World War II, approximately 500,000 M1 rifles had been produced. This number would grow to over 5 million by war's end. The rifle that American soldiers carried into combat weighed 9.5 pounds unloaded. It was 43.6 inches long. The gas-operated action was smooth and reliable. The rotating bolt locked securely. The trigger pull was crisp. And most importantly, it worked. Early combat experience in the Pacific revealed both the rifle's strengths and a few weaknesses. The N-block clip system, where 8 rounds were loaded together in a metal clip, was faster than loading individual rounds but had one notable characteristic. When the last round was fired, the empty clip was ejected automatically with a distinctive metallic ping. Japanese soldiers learned to listen for this sound, knowing it meant the American's rifle was empty. But this supposed weakness was largely myth. Experienced soldiers learned to reload before the clip was empty or would deliberately eject a partial clip to fool the enemy. The real advantage became clear in close-quarters jungle fighting. An American soldier with an M1 could fire 8 aimed shots in the time it took a Japanese soldier with a bolt-action Arisaka to fire 3. In sudden encounters where speed mattered more than long-range accuracy, the Garand was devastatingly effective. Marine Corps and Army after-action reports from Guadalcanal, New Guinea, and other early Pacific battles consistently praised the M1. One report stated that the rifle's rapid fire capability had prevented multiple American positions from being overrun during Japanese banzai charges. But it was in Europe where the M1 Garand would truly prove its worth and where German engineers would begin their reluctant admiration of American firepower. The first major encounter between German forces and American troops equipped with M1 rifles occurred in North Africa in November 1942 during Operation Torch. German and Italian forces, veterans of desert warfare, initially had little respect for the inexperienced American troops. The Germans were equipped with excellent weapons. The Kar 98K Mauser rifle was accurate, reliable, and proven. The MG-42 machine gun was the best in the world. German soldiers were experienced, well-trained, and confident. Then they ran into American infantry armed with M1 Garands. Obergefreiter Klaus Hartmann of the 10th Panzer Division recorded his first encounter in a letter home. We attacked an American position near Kasserine Pass. Our veterans expected easy victory against the inexperienced Americans, but their rifle fire was unlike anything we had experienced. It came in a continuous stream, not the methodical bolt-action fire we were used to. Each American seemed to fire as rapidly as our machine gunners. We took casualties we did not expect. Their rifles never seemed to empty. The tactical implications were significant. A German infantry squad typically had 9 men. One carried an MG-34 or MG-42 machine gun, the squad's primary firepower. The other 8 carried Kar 98K rifles primarily for self-defense and covering fire. The machine gunner was the key. Suppress or eliminate him and the squad's firepower dropped dramatically. An American infantry squad had 12 men. The squad's automatic weapon was the Browning automatic rifle carried by 1 or 2 soldiers. But unlike German squads, every single American rifleman carried a weapon capable of rapid, sustained fire. You couldn't suppress an American squad by taking out their automatic weapon. Every soldier was a threat. German tactics developed over years of combat experience suddenly required adaptation. Standard German doctrine emphasized fire and maneuver. One element would provide suppressing fire while another maneuvered to flank. This worked against enemies with bolt-action rifles because suppressing fire from Kar 98Ks could keep enemy heads down. Against Americans with M1s, suppression required machine gun fire. The rifles alone weren't enough. This meant German machine gunners, already priority targets, became absolutely critical. Lose the MG-42 and the entire squad was outgunned. American infantry tactics evolved to exploit this advantage. Squads would use their M1s to deliver overwhelming fire on German positions, forcing them to keep their heads down while the BR gunner moved to a better position. The sheer volume of semi-automatic fire from 8 M1 rifles was comparable to light machine gun fire from some armies. German soldiers began reporting that fighting Americans felt different than fighting Soviets or British. The continuous crack of Garand fire, 8 rounds in rapid succession followed by that distinctive ping, became associated with American attacks. Psychological effect was significant. Knowing that every enemy soldier could fire as fast as you could work your bolt created constant pressure. By early 1943, German intelligence had obtained several captured M1 Garands from North Africa and shipped them to the Waffenamt, the German Army Weapons Agency, for evaluation. The engineers who examined these rifles were impressed despite themselves. The initial report filed in March 1943 acknowledged the M1's technical sophistication. The weapon showed remarkable engineering. The gas system was reliable and self-regulating. The rotating bolt design was simple yet effective. The trigger mechanism was excellent. Most surprisingly, the rifle showed minimal wear despite obvious heavy use. American manufacturing quality was exceptional. But German engineers also noted what they considered weaknesses. The rifle was heavy compared to the Kar 98K. It was more complex and therefore more difficult to manufacture. It required closer tolerances and better machining. And most critically, it consumed ammunition at a much higher rate. The report concluded that while the M1 Garand was technically impressive, it was not suitable for German adoption. German industrial capacity was already strained producing existing weapons. Retooling for a new rifle would be impossible, and the ammunition consumption would exceed German logistics capabilities. This conclusion would prove to be one of the war's great miscalculations. What German engineers failed to appreciate was that the M1 wasn't just a better rifle. It represented a completely different philosophy of infantry combat. The Americans had designed their entire infantry system around the concept of overwhelming firepower. German doctrine emphasized tactical skill and combined arms coordination. Soviet doctrine relied on mass and numerical superiority. American doctrine assumed that individual soldiers with superior weapons could achieve tactical objectives with fewer casualties. The M1 Garand was the foundation of this philosophy. Give every soldier rapid-fire capability, train them to use it effectively, and they would dominate any firefight. Support them with excellent machine guns, mortars, and artillery, and American infantry became extraordinarily difficult to defeat. In Italy, where American forces fought from 1943 through 1945, the advantages of the M1 became even more apparent. The mountainous terrain meant that engagements often happened at close to medium range, where rapid fire was more important than long-range accuracy. German positions in Italian mountains and hills were formidable. Machine gun nests covered approaches. Mortars could drop fire on any assault. The terrain favored defense, but American infantry using M1s could deliver suppressing fire that forced German defenders to keep their heads down while other elements maneuvered. The 8-round capacity meant soldiers could maintain fire longer before reloading. The semi-automatic action meant they could engage multiple targets rapidly. German after-action reports from Italy consistently mentioned American fire superiority. One report from the fighting around Monte Cassino noted that American rifle fire was so intense that German soldiers initially believed they were facing machine gun positions, not rifle squads. The M1's reliability in harsh conditions also impressed German observers. The rifle functioned in mud, rain, snow, and dust. It required minimal maintenance. Soldiers could go days without cleaning, and the rifle would still function. The Kar 98K was also reliable, but the M1's ability to maintain function while delivering rapid fire was remarkable. By mid-1944, German weapons designers were seriously studying whether Germany could produce its own semi-automatic rifle. Several designs were already in limited production. The Gewehr 43, a semi-automatic rifle based partially on the Soviet SVT-40 design, was being issued in small numbers. But production was limited and the design had reliability issues. The Sturmgewehr 44, the world's first true assault rifle, was entering production but in small quantities and only for select units. Meanwhile, the Americans were producing 4 million M1 Garands and equipping every single infantry soldier with one. The industrial capacity difference was staggering. In June 1944, when Allied forces landed in Normandy, German defenders got their first sustained experience fighting large numbers of American infantry in European terrain. The results were sobering for German commanders. Omaha Beach was the bloodiest of the D-Day landings. German defenders in fortified positions had excellent fields of fire. They had machine guns, mortars, and artillery. American troops were landing on open beach with no cover, exactly the situation that favored defenders. Yet the Americans succeeded. Part of this success was due to overwhelming naval and air support. But German defenders reported that American rifle fire from troops who made it off the beach was far heavier than expected. Soldiers pinned down by machine gun fire were still able to return effective fire with their M1s, suppressing German positions enough for other troops to advance. Oberst Fritz Ziegelmann, Chief of Staff of the 352nd Infantry Division defending Omaha Beach, wrote in his after-action report that American infantry firepower exceeded all expectations. Individual American soldiers appeared to have the firepower of an entire German rifle team. Their semi-automatic rifles allowed them to maintain continuous fire while advancing or defending. Combined with their excellent light machine guns and abundant artillery support, American infantry proved extremely difficult to stop even when defending strong positions. As fighting moved inland into the hedgerows of Normandy, the M1's advantages became even more pronounced. Hedgerow fighting was brutal, close-quarters combat where engagements happened at ranges of 50 to 100 yards. Visibility was limited. Surprise encounters were common. The side that could put more rounds on target in the first seconds of contact usually won. The M1 Garand excelled in this environment. A soldier encountering an enemy position could immediately fire 8 rapid shots while taking cover. A German soldier with a Kar 98K could fire maybe 2 or 3 rounds in the same time while working the bolt. In the hedge fighting, this difference meant life or death. American squad tactics evolved to exploit this firepower advantage. Upon contact with the enemy, the entire squad would open fire immediately, putting out a volume of bullets that forced German troops to take cover. While the Germans were suppressed, the squad would maneuver to flank, or the bar gunner would move to a better firing position. German squads built around the machine gun as the primary firepower source couldn't respond the same way. Their riflemen provided supporting fire while the machine gunner engaged, but if terrain prevented the machine gun from firing effectively, the squad's firepower dropped dramatically. Hauptmann Wilhelm Schultz commanded a company in the 17th SS Panzergrenadier Division during the Normandy campaign. He wrote a detailed analysis of American infantry tactics that reached German high command in August 1944. The American infantry squad is organized differently than ours. Their philosophy is that every man is a source of significant firepower. They use their semi-automatic rifles to create a base of fire that equals or exceeds our machine gun fire. Once this base is established, they maneuver with remarkable speed. Our doctrine requires the machine gun to provide suppressive fire. If the machine gun is knocked out or cannot engage effectively due to terrain, our infantry is at a severe disadvantage. The Americans have no such weakness. Their entire squad can provide suppressive fire using only their rifles. This gives them tremendous tactical flexibility. I have seen American squads suppress and flank positions that should have held against twice their number. The rifle they carry is the foundation of this capability. By late 1944, the German military was desperately trying to address the firepower gap. They increased production of the Sturmgewehr 44, an excellent weapon but available in limited numbers. They tried to increase machine gun distribution to infantry units. But Germany's industrial capacity was being destroyed by Allied bombing, and resources were simply not available. Meanwhile, American production of M1 Garands continued at full capacity. The Springfield Armory and Winchester were producing over 10,000 rifles per week. Quality control was exceptional. Rifles coming off the production line were held to tolerances measured in thousandths of an inch. Each rifle was test-fired before acceptance. Replacement parts were interchangeable between rifles. American soldiers could swap bolts, operating rods, or barrels between any M1 rifles, and they would work perfectly. This interchangeability was critical for field maintenance. German weapons, while well-designed, often required hand-fitting of parts. A Kar 98K bolt might not work in a different rifle. This made field repairs more difficult. The M1's modular design meant that armorers could quickly repair rifles using standardized parts. A damaged operating rod could be replaced in minutes. A worn barrel could be swapped. The rifle could be maintained in the field without specialized tools. German engineers examining captured M1s in late 1944 produced a second detailed report that was far more complimentary than the first. The American M1 rifle represents superior design philosophy and manufacturing capability. The weapon is both sophisticated and reliable, a combination we have struggled to achieve. The gas system is elegantly simple. The rotating bolt is robust. The trigger group is well designed. But what truly impresses is the manufacturing quality. Every component is machined to exceptional tolerances. The steel quality is excellent. The surface finishing is superior to our own products. Most significantly, the rifle maintains these standards across millions of units. This level of consistent quality across mass production exceeds anything we have achieved. The report went on to note that attempting to produce a German copy of the M1 would be impossible. The machinery required, the steel quality needed, and the man-hours involved were beyond German capacity in 1944. Even if Germany could produce the rifles, equipping the entire army with them would require several years. Time Germany did not have. The report concluded with a remarkable admission. The Americans have fundamentally changed infantry warfare. They have given every soldier the ability to deliver rapid, accurate fire. This changes tactical calculations at every level. Our bolt-action rifles, while excellent for their type, are obsolete by comparison. We are fighting a modern war with weapons designed for the last war. This admission in an official German military document showed how completely perspectives had changed. In 1936, German observers had dismissed the M1 as unnecessary. By 1944, they recognized it as revolutionary. But recognition came too late to matter. In the Battle of the Bulge, Germany's last major offensive in the West launched in December 1944. The M1 Garand proved its worth in defensive combat. American infantry units, many of them green troops with limited combat experience, held off veteran German forces through sheer firepower. The 101st Airborne Division, surrounded at Bastogne, used their M1s to hold a perimeter against repeated German attacks. The defenders were outnumbered and outgunned in terms of armor and artillery. But individual American soldiers could deliver more rifle fire than their German counterparts. When German infantry attacked, they faced a wall of semi-automatic fire that was devastating. German soldiers interviewed after the battle consistently mentioned American rifle fire as a major factor in their failure to break through. One Obergefreiter stated that attacking an American position felt like attacking a position defended by twice as many men. Because of the volume of fire, the rapid-fire capability also gave American soldiers confidence. They knew that if they encountered the enemy, they had the firepower to fight back effectively. This psychological advantage should not be underestimated. A soldier who trusts his weapon fights more effectively. German soldiers in late 1944 and early 1945 were often equipped with worn-out weapons, limited ammunition, and decreasing confidence. American soldiers had new M1s, abundant ammunition, and the knowledge that their rifle was better than anything the enemy carried. Beyond combat effectiveness, the M1 Garand had characteristics that German engineers found remarkable from a technical standpoint. The rifle's accuracy was excellent despite its semi-automatic action. Bolt-action rifles are inherently accurate because the bolt locks up solidly and there are no moving parts during firing. Semi-automatic rifles have moving parts that can affect accuracy. Yet the M1 was accurate enough for effective fire out to 500 yards and could hit man-sized targets at that range consistently. The rotating bolt design was key to this accuracy. When locked, the bolt was as solid as any bolt-action design. The locking lugs engaged deeply. There was no slop or movement. The action was as rigid during firing as a fixed breech. German engineers testing captured M1s fired groups at various ranges. The results showed that the rifle was mechanically more accurate than the Kar 98K at ranges up to 300 yards. Beyond that, both rifles were limited more by the shooter and ammunition than by mechanical accuracy. But the M1 could fire 8 shots in the time the Kar 98K fired 2 or 3, meaning that even if individual shot accuracy was equal, the M1 put more rounds on target faster. The rifle's durability also impressed German evaluators. One test involved firing 10,000 rounds through a single M1 without cleaning or maintenance beyond basic lubrication. The rifle showed wear but continued to function. When the weapon was finally disassembled and inspected, the wear was within acceptable limits. The rifle could have continued firing. A similar test with a Kar 98K would have been pointless because bolt-action rifles don't have the same wear issues. But the fact that the M1's complex gas system and moving parts could withstand such abuse while maintaining function was remarkable. The steel quality in American weapons was noticeably superior to German equivalents by 1944. Germany was suffering from critical shortages of alloying elements like nickel and chromium. Steel quality had declined as Germany was forced to use substitute materials. American steel, produced in massive quantities with access to necessary alloys, was tougher and more durable. Captured M1 parts showed minimal wear even after heavy use. The barrel rifling remained sharp. The gas cylinder showed little erosion. The operating rod was straight and strong. By comparison, German weapons of the same period often showed accelerated wear due to inferior steel quality. The M1's N-block clip system, initially seen as a weakness by some, was actually quite clever. The 8-round clip was loaded into the rifle from the top. The rifle's action held the clip in place. As rounds were fired, the follower rose. When the last round was fired, the clip was automatically ejected with that famous ping. This system was faster than loading individual rounds and faster than removable box magazines of the era. A trained soldier could reload an M1 in under 3 seconds. The Kar 98K, loaded with 5-round stripper clips, took longer and required the bolt to be open. The rifle could be topped off by loading individual rounds, but this was slow. The M1 had to be completely emptied before reloading unless the soldier manually ejected a partial clip. But the 8-round capacity meant this was rarely necessary in combat. You fired your 8 rounds. The clip ejected automatically. You slammed in a new clip and kept firing. The process became automatic with training. German engineers noted that the on-block clip system, while unconventional, worked flawlessly. The clips fed reliably. The automatic ejection eliminated one manual step. The system's only real disadvantage was that clips were bulkier to carry than loose ammunition. But American soldiers were equipped with special clip pouches that held multiple 8-round clips securely. The M1's gas system was self-regulating in a way that impressed German designers. The rifle had no gas regulator adjustment. The system was designed to work with standard .30-06 ammunition, and it simply worked. German semi-automatic rifles like the Gewehr 43 often had adjustable gas systems because they needed to be tuned for different ammunition loads or environmental conditions. The M1 worked in desert heat, jungle humidity, Arctic cold, and European mud without adjustment. The secret was in the gas port size and the operating spring tension. These were carefully calibrated so that the rifle would cycle reliably with standard ammunition across a wide range of conditions. If the gas port was slightly clogged, there was enough excess gas flow to still cycle the action. If conditions changed, the system adapted automatically. This reliability without adjustment was a triumph of design. It meant soldiers didn't need to understand how the gas system worked or fiddle with settings. They just loaded and fired. The trigger mechanism was another area where German engineers acknowledged American superiority. The M1's trigger was a 2-stage design with a clean break. The first stage took up slack. The second stage broke cleanly at around 5.5 pounds of pressure. This gave shooters good feedback and allowed accurate shooting. German rifles generally had heavier, less refined triggers. The Kar 98K's military trigger was functional but not particularly good. The lack of a safety mechanism that locked the trigger was one design choice that some criticized, but American doctrine emphasized that soldiers should keep their fingers off the trigger until ready to fire, making a trigger lock unnecessary. The M1's operating system used a long-stroke gas piston. This meant the operating rod traveled the full length of the action, pushing the bolt carrier rearward. This system was robust and powerful. It ensured reliable extraction and ejection even with dirty ammunition or fouled chambers. German semi-automatic designs often used different systems. The Gewehr 43 used a short-stroke gas piston combined with a tilting bolt. This was more compact but also more sensitive to fouling. The M1's system was more tolerant of abuse. One aspect that German engineers found wasteful but had to admire was American willingness to use advanced manufacturing techniques. The M1's receiver was forged and then machined. This process was expensive and time-consuming but resulted in exceptional strength. German weapons, especially later in the war, increasingly used stamped parts welded together. This was faster and cheaper but generally resulted in lower quality. American industry had the capacity to do things the hard way because they had the machinery, the skilled workers, and the time. German industry by 1944 was forced to take shortcuts just to maintain production. The M1's barrel was another example of manufacturing quality. American barrels were made from excellent steel, properly heat-treated, and rifled with precision. The rifling used a 1.10-inch twist rate, meaning the bullet completed one full rotation every 10 inches of barrel length. This provided excellent stability for the .30-06 bullet. German barrels were also good, but quality control was becoming inconsistent by late war. Some German weapons showed rough rifling or uneven heat treatment. American barrels maintained consistent quality throughout production. The M1 also benefited from American standardization of ammunition. The .30-06 cartridge was loaded to consistent specifications. Bullet weight, powder charge, and overall cartridge length were tightly controlled. This consistency meant rifles could be designed around specific ballistic characteristics and they would perform predictably. German ammunition quality declined as the war progressed. Shortages of materials led to substitute gunpowders and inconsistent bullet manufacture. This affected weapon performance and reliability. Even the best German rifles were hampered by declining ammunition quality. The M1 Garand's impact on infantry tactics was so significant that German tactical manuals had to be revised. Pre-war German doctrine assumed that enemy infantry would have similar bolt-action rifles. Tactics were designed around this assumption. By 1944, German manuals specifically addressed fighting American infantry equipped with semi-automatic rifles. The manuals emphasized the need for immediate and overwhelming machine gun fire to suppress American positions. They warned against attempting to outshoot American infantry in a firefight. The recommendation was to use grenades, mortars, and machine guns to neutralize American positions rather than engaging with rifles. This was an implicit admission that German infantry rifles were outclassed. The manual's acknowledgement that German riflemen should avoid direct firefights with American riflemen showed how completely the tactical calculus had changed. In the Pacific theater, the M1 Garand's advantages were even more dramatic. Japanese infantry primarily used the Arisaka Type 99 rifle, a good bolt-action design but limited by its smaller cartridge and 5-round magazine. In jungle fighting, where engagements happened at close range, often with poor visibility, the M1's rapid-fire capability was decisive. Japanese tactics often involved surprise attacks and close assault. These tactics worked against troops with bolt-action rifles who could fire only a few rounds before being overrun. Against Americans with M1s, the same tactics resulted in devastating casualties. American soldiers could fire 8 rapid shots into charging Japanese troops, delivering enough firepower to break attacks that would have succeeded against bolt-action armed defenders. After-action reports from Pacific battles consistently praised the M1. The Marine Corps, initially resistant to giving up their Springfield bolt-action rifles, became enthusiastic M1 advocates after combat experience. Marine General Joseph Stilwell famously said that the M1 Garand was the finest implement of battle ever devised. His opinion was shared by virtually every American soldier who carried one in combat. Japanese forces captured some M1 rifles and sent them back to Japan for evaluation. Japanese engineers were impressed by the design, but concluded that Japan lacked the industrial capacity to produce such weapons. Japanese attempts to develop semi-automatic rifles generally failed due to complexity and manufacturing difficulties. By 1945, the superiority of the M1 Garand over bolt-action rifles was so obvious that it influenced post-war weapon development worldwide. Every major military began developing semi-automatic or select-fire rifles. The era of the bolt-action battle rifle was over. The Germans, despite their late recognition of the M1's superiority, did influence post-war rifle design through the Sturmgewehr 44. This assault rifle, firing an intermediate cartridge and capable of both semi-automatic and full-automatic fire, represented a different solution to the firepower problem. But it arrived too late and in too few numbers to affect the war's outcome. The M1 Garand, available from 1936 and issued in millions, had already changed infantry combat forever. In the final months of the war, as Germany collapsed, German soldiers who surrendered often asked American troops about their rifles. Many wanted to examine the M1, curious about the weapon that had dominated so many firefights. Captured German documents show that Wehrmacht intelligence maintained detailed files on American weapons. The M1 Garand file was extensive. It included technical drawings, performance data, manufacturing information, and tactical assessments. The final assessment, written in March 1945, was brutally honest. The American M1 rifle is the most effective standard infantry weapon of the war. Its combination of firepower, reliability, and accuracy gives American soldiers a decisive advantage in infantry combat. Our failure to develop and field a comparable weapon in sufficient numbers is among the critical factors in our defeat. This admission from German military intelligence was remarkable. They were acknowledging that a single weapon design had strategic impact on the war's outcome. While this was certainly an overstatement, no single weapon wins wars. It reflected the degree to which the M1 had impressed even its enemies. The rifle's service life extended decades beyond World War II. The M1 Garand served in Korea, where its advantages over communist bolt-action rifles were again demonstrated. It remained in U.S. service until replaced by the M14 in the early 1960s. Many Allied nations received M1 Garands through military aid programs and used them for decades. The design influenced numerous subsequent rifles. The Italian BM-59, essentially an M1 modified for a detachable magazine and select fire capability, served into the 1990s. The M14, America's next standard rifle, used an operating system based on the M1's design. From a technical standpoint, the M1 Garand represented the perfect balance of complexity and reliability for its era. It was sophisticated enough to provide semi-automatic fire, but simple enough to be produced in massive quantities and maintained in field conditions. This balance was John Garand's greatest achievement. Modern firearms designers still study the M1. Its rotating bolt design is mechanically elegant. The gas system is a model of self-regulating simplicity. The overall package, while dated compared to modern rifles, was revolutionary for its time and remains influential. German engineers' admiration for the M1 Garand grew from initial skepticism to reluctant respect to genuine awe. In 1936, they dismissed it as unnecessary. In 1943, they acknowledged it was impressive but unsuitable for German use. By 1945, they recognized it as one of the war's most important weapons and a key factor in American infantry superiority. This evolution in German thinking reflected the M1's combat record. Every encounter between German and American infantry reinforced the lesson that semi-automatic fire was a decisive advantage. The rifle didn't just give American soldiers more firepower. It gave them confidence, tactical flexibility, and a weapon they could trust in any conditions. Hans Weber, the German soldier who first heard that distinctive ping on Omaha Beach, survived the war. In a 1978 interview, he was asked what he remembered most about fighting American troops. Without hesitation, he answered the rifles. Their rifles, he said, were better than ours. We knew it. They knew it. When you heard that fast crack, crack, crack of their Garands, you knew you were facing soldiers who could shoot back harder and faster than you could shoot at them. It was frightening. We had been taught that German weapons were superior, that German engineering was the best. The American rifle proved that was propaganda. They had out-engineered us, and we paid for that failure with the war. The M1 Garand's technical specifications tell part of the story. Semi-automatic operation, 8-round capacity and 30.06 Springfield chambering. Gas-operated rotating bolt. But the real story is in what those specifications meant for the soldiers who carried it, and the enemies who faced it. An American infantry squad in World War II carried 96 rounds of immediately available firepower in their M1 rifles alone. That didn't count the bar, the carbines carried by some soldiers, or pistols. Just the 8 M1 rifles held 96 rounds ready to fire. A German squad with 8 Kar 98K rifles held 40 rounds, less than half. And those 96 American rounds could be fired far faster than 40 German rounds. In a sudden encounter, the American squad could deliver nearly 100 rounds in the first few seconds. The German squad might deliver 20 or 30. This raw firepower advantage meant American squads could seize initiative immediately. See the enemy, fire, keep firing while maneuvering. German doctrine required more careful coordination because individual riflemen had less firepower. The psychological impact extended beyond the soldiers carrying M1s. German soldiers facing American infantry knew they were outgunned at the individual level. This knowledge affected morale, especially late in the war when German forces were already stretched thin. The famous ping of the ejecting clip, often cited as a weakness, had minimal actual tactical impact. The sound was usually masked by other battle noise, and even if an enemy heard it and charged, the American soldier could reload in under 3 seconds. Few enemies could cover enough ground in 3 seconds to exploit an empty rifle. What Germans actually learned to fear was the sound of M1s firing. The rapid crack of semi-automatic fire, multiple rifles firing in quick succession, that was the sound that meant American infantry were engaging. It meant you were about to face more bullets than your bolt-action rifle could answer. Some German veterans reported developing an almost instinctive reaction to that sound. Hear the Garands firing, take cover immediately. The American advantage in logistics also played a crucial role in the M1's effectiveness. American supply lines could provide abundant ammunition. Soldiers were rarely short of rounds for their rifles. This meant they could use the M1's rapid-fire capability without worrying about running out. German soldiers, especially late in the war, often faced ammunition shortages. Even when equipped with good weapons, they had to conserve ammunition. This forced them to be selective about when they fired, giving up one of infantry combat's key advantages, suppressive fire. American infantry could use suppressive fire freely, pin down the enemy with volume of fire while maneuvering. German infantry had to be more conservative, which limited their tactical options. The M1 also proved remarkably adaptable. It could mount a bayonet for close combat. It could launch rifle grenades from a special launcher fitted to the muzzle. Some were fitted with optical sights for designated marksman use, though this was not common. The rifle worked in every climate and condition American forces encountered. From Arctic cold to tropical heat, from North African desert to European mud, the M1 functioned. This reliability across such varied conditions showed the robustness of the design. John Garand had created a weapon that simply worked. German engineers, examining captured examples throughout the war, conducted increasingly detailed analyses. They measured dimensions, tested materials, studied the heat treatment of parts. They were trying to understand not just how it worked, but why it worked so well. What they discovered was that American manufacturing quality was consistently higher than German equivalents by mid-war. Parts tolerances were tighter, surface finishing was better, heat treatment was more uniform. The machinery used to produce M1 parts was often more advanced than German equivalents. American industry had invested heavily in precision machine tools, automated production equipment, and quality control systems. This investment paid off in weapons that were both sophisticated and reliable. Germany had excellent engineers and designers, but increasingly lacked the industrial capacity to match American production quality. The Waffenamt reports on the M1 Garand became progressively more detailed and more admiring as the war continued. Early reports were technical assessments. Later reports included tactical analysis of how the weapon affected combat. The final reports, written in early 1945, were almost wistful. They described a weapon that Germany could have built if they had started earlier, if they had access to resources, if they had American industrial capacity. By late 1944, some German units facing American forces had standing orders to recover M1 Garands from battlefields. Not for intelligence purposes, enough had been captured and analyzed. They wanted them to use. German soldiers, when they could obtain ammunition, would use captured M1s in preference to their own Kar 98Ks. This was perhaps the ultimate admission of the American rifle's superiority. Soldiers generally prefer familiar weapons. Training, muscle memory, and confidence come from using the same weapon repeatedly. Yet German soldiers who had the choice would take the unfamiliar M1 over their standard-issue Kar 98K. After-action reports mention several instances of German troops using captured American weapons. The M1 was among the most prized. The fact that enemy soldiers wanted to use your weapon instead of their own is probably the highest compliment a military firearm can receive. Soviet forces also captured M1 Garands, primarily in the Pacific, where some American equipment fell into Soviet hands after they entered the war against Japan in August 1945. Soviet engineers examined these rifles with interest. The Soviets had their own semi-automatic rifles, particularly the SVT-40, but these had mixed success. The SVT-40 was a good design but sensitive to maintenance and difficult to manufacture. Soviet infantry primarily used the Mosin-Nagant bolt-action rifle. Soviet assessments of the M1 were similar to German ones, technically impressive, well-made, effective in combat. But also, like the Germans, the Soviets concluded that manufacturing such weapons in quantity would require industrial capacity they could better devote to other weapons. The difference was that the Soviets had a different solution: the submachine gun. Soviet doctrine emphasized close-range firepower provided by simple, cheap submachine guns like the PPSH-41. These provided rapid fire at close range with minimal manufacturing complexity. For the Soviets fighting at close ranges on the Eastern Front, this worked. The Americans had chosen a different path: high-quality semi-automatic rifles for every soldier. More expensive, more complex, but also more capable at medium ranges. The M1 Garand represented American industrial philosophy perfectly. When you have the manufacturing capacity, don't build cheap weapons in huge numbers. Build excellent weapons in huge numbers, give every soldier the best possible equipment, and trust American industry to produce it. This philosophy extended beyond rifles. American machine guns, artillery, vehicles, aircraft, all were built to high standards and produced in enormous quantities. Germany and other nations had to choose: build more weapons of lower quality or fewer weapons of higher quality. America didn't have to choose. They built high-quality weapons in vast quantities. The M1 Garand production figures illustrate this. Over 5.4 million M1 rifles were produced during World War II. Each one met strict quality standards. Each one was test-fired before acceptance. The rejection rate for M1 rifles was low because production processes were so well controlled. By comparison, Germany produced about 7.5 million Kar-98K rifles during the war. More total rifles, but the Kar-98K was much simpler to manufacture. Producing 5.4 million M1 Garands with their complex gas systems and tight tolerances was a far greater manufacturing achievement than producing 7.5 million bolt-action rifles. The labor hours required to produce an M1 were nearly double those needed for a Kar-98K. Yet American industry produced them by the millions without straining capacity. This industrial strength was as important as the rifle's technical merits. The best designed weapon is useless if you can't produce enough of them. German engineers developed several excellent firearms during the war. The MG-42 machine gun, the Sturmgewehr 44, the Panzerfaust anti-tank weapon. But many of these arrived late or in limited numbers because German industry couldn't match Allied production capacity. The M1 Garand was available in unlimited quantities from 1943 onward. Every American infantry soldier had one. Replacements were always available. Spare parts were abundant. This availability was as much a part of the weapon's success as its design. John Garand lived to see his rifle become legendary. He continued working at Springfield Armory until his retirement in 1953. He received honors and recognition for his achievement, but remarkably little financial benefit. The M1 rifle was developed while Garand was a government employee, so the design belonged to the government. Garand never received royalties or significant compensation beyond his salary. There were efforts to award him special compensation, and he received some payments, but nothing proportional to the rifle's impact. He died in 1974 at age 86, honored but not wealthy. His legacy was the rifle that bore his name and the millions of soldiers who carried it. The M1's influence on firearms design cannot be overstated. It proved that semi-automatic rifles could be reliable, accurate, and suitable for general infantry use. It demonstrated that increased firepower at the individual soldier level changed infantry tactics fundamentally. Every modern military rifle descends from lessons learned from the M1 Garand. The rotating bolt design, gas operation, semi-automatic fire, these became standard features. The assault rifles that replaced battle rifles like the M1 used smaller cartridges but retained the basic operating principles. German engineers' admiration for the M1 Garand was grudging but genuine. They recognized superior design when they saw it. More importantly, they recognized that the rifle represented something beyond just good engineering. It represented a nation that could design sophisticated weapons and produce them in overwhelming quantities. That combination, technical excellence plus industrial capacity, was something Germany could not match. In the end, that mattered more than any single weapon. But the M1 Garand was the symbol of American material superiority, and it was a symbol that German soldiers faced in every infantry engagement from 1943 onward. The distinctive sound of the Garand became associated with American forces. The ping of the ejecting clip, the crack of rapid semi-automatic fire, these sounds meant Americans were present. For Allied soldiers, those sounds were reassuring. For German soldiers, they were ominous. General George Patton called the M1 Garand the greatest battle implement ever devised. This was typical Patton hyperbole, but it reflected genuine respect for the weapon. Patton understood infantry combat and knew that giving soldiers superior weapons saved lives and won battles. Erwin Rommel on the German side made similar observations about American equipment superiority. His forces in North Africa faced American infantry armed with M1s and supported by excellent artillery and air power. Rommel noted that American soldiers were often inexperienced, but their equipment was superb. Give those soldiers time to gain experience, Rommel warned, and they would be formidable. He was right. By 1944, American infantry combined experience with superior equipment. The result was an infantry force that German units could rarely defeat in equal numbers. In situations where German and American infantry engaged without armor, artillery, or air support, just rifles against rifles, the Americans usually won. The M1 gave them that edge. Could Germany have developed a similar rifle? Technically, yes. German engineers were certainly capable of designing semi-automatic rifles. They produced the Gewehr 41 and Gewehr 43, both semi-automatic designs. But neither was as successful as the M1. The Gewehr 43 came closest. It was reliable enough and saw service from 1943 onward. But it was produced in far smaller numbers, only about 400,000 total. Compare that to 5.4 million M1 Garands. The Germans simply couldn't match American production capacity. Even if they had started earlier and devoted more resources to semi-automatic rifle production, they likely couldn't have equipped their entire army. German industry was producing tanks, aircraft, submarines, artillery, and countless other weapons. Resources were limited. Adding massive semi-automatic rifle production would have meant cutting something else. The Americans didn't face that choice. Their industry could produce everything in abundance. By 1943, American factories were outproducing all Axis nations combined in nearly every category of military equipment. This industrial supremacy meant that American infantry carried the best rifles, rode in the best trucks, ate the best rations, and were supported by the best artillery and air power. German soldiers late in the war often remarked on the material disparity. They were hungry. Their uniforms were worn, their weapons were often in poor repair, and ammunition was scarce. American soldiers were well-fed, well-equipped, and never seemed to run out of supplies. The M1 Garand was emblematic of this disparity. It was a weapon that said, "We have the resources to give every soldier a sophisticated semi-automatic rifle, and we have the ammunition to let them use it freely." That message, delivered through millions of M1s in the hands of Allied soldiers, was as important as the rifle's technical characteristics. German engineers' journey from dismissing the M1 to admiring it mirrors Germany's journey through the war. Early confidence gave way to respect for enemy capabilities and finally to acknowledgement of material inferiority. The Waffenamt reports on the M1 Garand document this progression. The rifle itself was just a tool, but it was a tool that reflected broader American advantages in design philosophy, manufacturing quality, industrial capacity, and logistics. When German engineers studied captured M1s, they weren't just examining a rifle. They were confronting evidence of American superiority in multiple domains. That realization, more than any single battle or campaign, showed German military leadership that the war was unwinnable. You can't defeat an enemy who can produce millions of sophisticated weapons, while you struggle to produce thousands. In the final accounting, the M1 Garand was one of World War II's most important weapons. Not because it was a wonder weapon that single-handedly won battles, but because it gave millions of American soldiers a significant advantage in the most common form of combat: infantry firefights. Every engagement where American and German infantry traded shots was influenced by the M1's rapid-fire capability. Across thousands of such engagements over 2 years of war in Europe, those advantages accumulated. The rifle helped American infantry win firefights they might have lost with bolt-action rifles. It saved lives by allowing American soldiers to put more rounds on target faster. It gave American squads tactical flexibility that German squads lacked. and it served as a symbol of American industrial and technical capability. German engineers who examined the M1 Garand saw a weapon that was better than anything they had produced for general infantry use. That was a bitter pill to swallow for a nation that prided itself on engineering excellence. But it was the truth, and by 1945, even German military reports were acknowledging it. The M1 Garand had earned the respect of its enemies through 4 years of combat. And that respect, grudging as it was, stands as tribute to John Garand's achievement and American industrial might.